Hi everyone, my name is Catherine and I will be your guide today as we explore modelling the spread of disease using the turtle system. I'm the STEM Outreach Officer for Hertford College at the University of Oxford, and someone else who works here at Hertford is this guy, Professor Peter Millikan, a guru of all things computer science and philosophy. He developed a project called the Turtle System, which is designed to let anyone have a go at computer programming, even if they have zero idea what they're doing. So, for the next 30 seconds, let's talk about the Turtle System. Computer programming can be tremendous fun as well as educational, and the best way to start learning to program is indeed to have fun, to experience the pleasure of intellectual creativity as you capture your imaginative ideas in computer code. Unfortunately, the sophistication of many programming systems gets in the way here, with lots of new concepts and techniques required before the novice is able to apply any creative ideas. To get over this daunting hurdle, it is helpful to start programming in a system which is intuitively natural and where technical complications are kept to a minimum. A wonderful way of achieving this, which has since been very widely copied, was invented by Seymour Papert with his idea of turtle graphics, based on the metaphor of a turtle moving around the computer screen and drawing as it goes, all under the control of instructions given by a computer program. This sort of programming and the results it produces are easy to understand because they are so immediately visual. But the turtle system provided here shows that Papert's idea can go well beyond simple graphics to provide a basis for fascinating and powerful programs that introduce fundamental concepts of software engineering and artificial intelligence. So that's the turtle system, but why is it interesting and relevant now? Well, one of the programs you can play with models the spread of a disease, which is somewhat pertinent in the current climate. You can, of course, explore many other models and programs in the turtle system, but this one seems like a good starting point right now. First up, though, what is a model? In more than one sense, it's a simple version of part of the world that we can play around with and control. A mathematical or computer model is a representation of part of the world in equations or code and can be very simple or very complex, with lots of different variables and dependencies and considerations and so on. Once you've built a model, you can use it to simulate something, to suggest answers to the question, what would happen if something? Because we're using Turtle, we don't have to build our model from scratch. We can start running simulations straight away and then play with the model later. So, let's get started.